You're good to go.
Hi, welcome to today's session, Industrial Use of Holograms with Virtual Reality. Get to the right share here. I'm Steve McKay. I'm with Canadian Natural, and I'm the integration coordinator. I've been in different parts of the business for the last 33 years in IT and engineering, and I've worked in petrochemical, oil and gas, and food manufacturing. And one of the things that I've done over the course of my career is using 3D models for engineering. Started off with construction of different facilities, using them for operational use. And that's one of the things that has been lucky enough in my career to be part of driving visualization. Currently at Canadian Natural, I'm accountable for our engineering design tools and how we deliver them, working with our IT group. And also, how do we continue to leverage 3D models at Canadian Natural? I'm a senior member of the team that's been developing augmented reality and virtual reality the last 4 years. And I'm also one of the company evangelists for how we can take advantage of this technology. So Canadian Natural has used 3D models for visualization for the last decade. This is something that we've done right from the beginning all the way through. And in a lot of industries, you see the use of these 3D models traditionally on a flat screen, printed on a wall, and things that you use. But we've been using them for the last decade plus. So the question we ask is, where do we go from here? So our inspiration is looking at video games. So why do we look at video games for the next generation of visualization? There's some really important aspects about why we do that. If we look at the history of video games, what have they taught us? They've taught us that we learn by engagement. That is how we learn. We pick up the controller, we interact with that world. We do things, we throw rocks in the water, we go down this thing, we unlock that, we find the magic castle. And by interacting in that world, we learn by controlling a character. We learn by doing. So VR gaming is something that's started to happen over the next number of years as well. So the question is, what has that shown us? Well, it's the power of immersion and experience. So we're taking that flat screen and really wrapping it around your head. Well, what does that mean? Oh, sorry, get to that.
All right, hyperdrive controls are active. Make the jump to light speed.
So by making you the character, we shift from a third person type of interaction to a first person. You are in that world. And I apologize for some of the jerkiness if there is on the streaming. It's kind of hard to show VR, in a presentation type of environment. But what I'm trying to say is that when you actually put you in that world, video games take that world and put you in there. So that video clip that I just showed, you are sitting in that front of that starship as I clunkily try and pull the lever to take us to warp. You are in that environment, and that becomes a huge potential for where we look at our next step. So because we have at Canadian Natural, we have the 3D model of our entire plant. Let's make an industrial game. So let's take traditional models we have and let's put it in a video game development engine. So we're using Unity. Unreal Engine is another one of the tools that is used for video game development. So we're using these same tools in order to create an industrial version of that, right? So instead of just looking at, for example, this structure that I'm showing on the left, why don't we actually put you in that structure? What a great idea. So let's take these same video game techniques that are being done to create VR games, and let's actually put you in there. So let's show you that. All right, let's take a walkthrough of 44C10 in VR. So if we take a look a little bit farther back, we can see the structure itself, and we've made the vessel blue glass so you can see through it. And what we'll do is we'll actually walk around it and we can see the scope of the work that needs to happen for the next turnaround. So let's go into one of the platforms now and take a look. As you look inside the vessel, here we'll see the red trays that are staying, and then in the bottom we can see some scaffolding that's built. That'll be their support. And then we can look up. VR gives you the perspective of actually being there, so we can lean in the railing and look up, and we can see above us of what is inside that particular vessel. And we can look around. So let's go up one more floor and we can see the top of that structure that's being supported inside the vessel from the scaffolding. So let's get to standing level and move over to the railing, and then we can look down. This gives us insight to how restrictive it's going to be to do any kind of maintenance work and actually experience it. So let's go up another floor. This is a good indication of the yellow is the trays that need to come out. We'll just move over and get a better view. And the red is the trays that are staying, but the red is going to be how we get access to it. Oh, we've got a worker over there. And we see the challenge of having to remove some of the red in order to get access to the trays marked in yellow, to demo those and get them out through the top of the vessel. And we can see down into the vessel just how much space and restriction we actually have. So let's actually go inside the vessel. We can go inside the blue glass, and we can actually stand on top of that tray, and we can see the grating and the bolts holding the grating together. And we can actually take a really good look down. Oh, I kind of overshot that one a little bit. Let's go back in. And I can look over as if I'm standing on that grating. I can see through the floor, and I can actually see what I'm going to have to unbuckle and undo in order to get access to the trays down below. So that it's kind of hard to show completely on a flat screen, but that's an example of taking that same type of VR gaming ideas and concepts and workflows and actually taking our model and putting you in the model. And that's a huge experience for our folks, is that, there's areas of the plant that you can't get into. It's running, it's hard to get in there and understand. And there's only so much you can use on a flat drawing or a flat screen of a 3D model. But actually taking those same concepts and ideas and putting you in the structure, as you saw in that video, you can now get a sense of space. You can start to think about how you're going to plan. Here's an example of a furnace, right? We can put you in the furnace and start to walk around and actually understand how things are put together, how big things are, how things actually connect. And going back to my slide earlier, you can interact with it. You're totally immersed in that environment. So here's an example of immersion. We have a number of VR rooms at our plant site and in our head office where somebody has a headset, we're cabled up. And in this example, he's walking through one of our fractionator towers, trying to get an understanding of a big maintenance job that's being planned, right? He's actually, doesn't know he's standing in this small little room. To him, he's inside that structure. And again, just like the same example, we have the vessel itself is blue glass, so you can kind of look inside of it from that point of view. So the other thing that we're looking at is augmented reality. Now, one of the references, again, looking at gaming for augmented reality is there's a lot of people that understand it by Pokemon Go. So I try and explain what we're trying to do with augmented reality and trying to make the industrial version of that using Pokemon Go. So here's a couple snapshots of me trying to collect Pokemon in my living room. And like everybody else, I'm working from home. So that's where a lot of these screenshots are from. So here's an example. Let's take that same concept of Pokemon Go and augmented reality, which is really holograms on top of reality. That's what we're really talking about. So really talking about the power of holograms. So in this case, I built a demo to teach my son how to make me coffee. I thought that if everybody learned how to make me coffee, this would be a much happier world. So here's an example where we've got a floating hand and we've got a bunch of instructions that we can teach somebody how to do training. So that's great, Steve, that's coffee. So here's an example. One of my team members went down in his basement and created one training against his basement heating. So this is an example of what that looks like. I'm just going to show a little 2-minute clip showing of what that looks like.
Let's become familiar with the equipment in the heating system. A photo shows us where it is and what it's called. We also see holographic numbers, which are situated around major pieces of equipment in the heating system. Number 8 is a boiler. Number 1 is a valve. Number 7 is an indirect fired hot water heater. 2 is a valve. 6 is an aquastat. 5 is a pump. 3 are the control zone valves. And number 4 is a toggle switch which turns the water pump on and off. Once you're familiar with the equipment, proceed to the next step. In this step, you're instructed to turn the main supply valve to the open position. A photo shows us what a off and open or on position valve looks like. A tether and a giant floating hand point us exactly where that valve is located. It's currently already on. I'm just going to pretend like I'm turning it on, which completes that step and automatically takes us to the next one. In this next step, we're instructed to turn on the supply line for the secondary valve. Photo shows us what the off and the on position look like. The tether and the hand show us where it is. It's currently on. I'm going to mimic turning it on, which completes that step automatically. Takes us to step 6, which instructs us to open the control zone valves. Photo shows us where they are. Here you see they're already open. Just going to double check. Yes, they're open. That last action completes that step automatically, takes us to the step 7. We're asked to locate the supply box for the power and set the toggle switch to on. It's currently on already. I'm just going to pretend like I'm turning it on, which completes that step. Takes us to step 8, which instructs us that we've successfully started our system. Let's see what else we can learn. The hydronic heating system demonstrated in this guide consists of a boiler as the main heating source, as well as an indirect water heater that heats water for both the 4 underfloor zones, as well as the domestic hot water supply. Special care must be taken to ensure.
So what you see there is a perfect example of where the next generation of training is going to become, right? So the ability to put holograms on actual equipment or put holograms against virtual pieces of equipment. So go back to the original part of my presentation. Canadian Natural has our entire plant. So we can take, a piece of equipment or a structure, put it as a hologram, and then create training around it. So it becomes a very new method of creating better training and more efficient training. People are visual thinkers, right? So the ability to practice and learn against the actual equipment or a virtual version of it allows you to go through the next generation of training and visualization. So for us as Canadian Natural, augmented reality, which is really holograms, right? Today it's a headset, tomorrow it could be a table, after that it's a room. That's really the key aspect that we're focusing on in order to take advantage of how we train our people. So when we start to think about holograms, we're very familiar with augmented reality in movies, right? We see, how to go through the spaceship to go rescue the Palpatine, to the very first hologram I ever saw in 1977 was Star Wars. And then the big thing that is one of our guidances and one of our aspirations in our head of everybody sitting in a room and having a holograph of something that we're making a decision against, right? So this is what we're doing today. So we have holograms and augmented reality at work. So we're using Microsoft's HoloLens, and we've got some of our pieces of equipment that we can bring into a meeting room. We can put part of that frac tower that I showed that fella going through in VR. We can actually put it on a table and look at it. Down below is our version of that same room full of people looking at holograms that are floating there. So what we're building at Canadian Natural is how do we keep iterating holograms as augmented reality? The technology will continue to improve, but all the things that we're doing start to lead into that support. So why is AR VR an opportunity? So some of the things we've heard as we've started to get into this was, if I could just take you out to that area, I could show you what I mean, right? So our operational people say, oh boy, if I could just take you out there, but it's 42 below, or there's other pieces of equipment in the way. I wish I could do that. Well, what if you could? I wish I could have this piece of equipment in the room. So for example, let's say I'm a supervisor and we've got something we need to deal with. One of the people in the field, we can bring a hologram up on the table and we can walk around and look under it and talk about it. What if we could do that? How do we train people better? How do we actually have them experience while they're learning? What if we could do that? How do we train for unplanned events, right? So one of the things we want to do is safety and reliability, right? So how do you practice for unplanned events and major events, right? You don't want to learn the hard way. So how about we simulate that? How about we use the power of virtual reality to completely put you there and then create a simulation, right? What happens if you turn the wrong valve? What happens if this happens? How are you going to react, right? That allows people to learn, understand, and get better. So this level of immersion that we're talking about with both VR and AR let us do these things. So the gamification is really, really important. As we move towards this type of visualization, a lot of the way and the approach and the workflow and the methods have already been developed, have already been iterated, game console after game console. And even VR for gaming is an adaptation of how console gaming was built and PC gaming was built. So the real core message here is adapting video game development workflows and techniques allow us to take this next step. So a lot of the training that we're taking, a lot of the people that we're hiring are in that industry, are looking at how to adapt that. So from an engineering point of view, this becomes a huge set of tools to experience and use as part of your planning, your training development, your understanding, your orientation. One of the visions we have is as we hire new people, we can put a headset on them and walk them around the plant and the facility, and we can talk about it. Something you really would like to do in person, but how can you do that in an operating facility? So there's lots of potential for where this needs to go. And for us, it's a 5 to 10 year journey as we let technology get better and we keep increasing it. We're continuing to expand and leverage where Canadian Natural can use these 3D models that we already have and we keep up to date. How do we keep pushing and pushing as the new technology advances? So that's the presentation, and that's what we're doing at Canadian Natural with industrial VR and AR. So any questions I'd sure like to take.
Okay, so we have one question. It's essentially saying, in terms of visualization, it's evident that there are many benefits and applications to implementing VR. However, what are some challenges of gamifying 3D models, and how hard is it to do?
So it is a huge challenge. When we take a look at 3D models that are generated, if you look at the history of engineering, it started out as 2D CAD, and then we have a 3D view of that 2D CAD, and then it's used to create some of the snapshots I showed earlier. But the format and some of the graphics themselves don't easily adapt to the video game technology and the development systems. So we've had to work our way over the number of years to figure out what that workflow is to adapt it. And there's a lot of things that we're still trying to figure out that don't work quite as well. Sometimes we have to remodel some stuff. Sometimes we just can't put as much stuff in it as we'd like. But it's a challenge when you start getting into this type of development. You really need to understand your starting data. When you build a video game, you create all that set or the background or the plant in this case from scratch. In this particular case, you have a different source material. So it's a really big challenge to understand your source material, where it comes from, what you can and can't do, and also how does the video game industry deal with that? They're dealing with the fact that these headsets have got a limited technology. So there's new tricks, there's new techniques. So understanding both your source and the current development tools is really the way you get there.
Okay, awesome. Another question, how difficult is it to implement this into your business? And just to add on to that, how receptive are industry leaders in regards?
I can only speak for Canadian Natural. They're ecstatic and they can't wait and they wish we could get it in quicker. Because if I go back to my original statement, we've had 3D models on everybody's desktops. We've got over 2,000 people that have access to the models on the desktop. So using our 3D model is an ingrained process for our workers and our management to expect that. So as we've introduced, what we've done is we've done proof of concepts and pilots, and we've showed it to our businesses, and we've gotten feedbacks from our turnaround planning to our reliability to maintenance to health services to emergency response, even to management. And they've been excited. It's one of those technologies that unless you've tried VR, you don't really get it. When you put a headset on, we always joke that we see people, they tilt their head back to look at a big structure and we swear we hear a click in their brain. And we know they get it. And once they get it, they're hooked. They totally understand the power of actually being there. And have very supportive management that has given us the time as we continue to prototype to try stuff and throw it out. They're very understanding of the limits of the technology. And they also buy into a 3 to 5 to 10 year roadmap as you wait for technology. But I think as you try and bring it into a business, you have to prototype small demos, small little experiences, right? The example that I showed earlier of somebody going around the structure, that's important to put a headset on. Yeah, you can't click on everything and get information and bring up drawing, but you can walk around it. It's spatially correct. So I think understanding where you get that, and then the feedback is important. We've probably tried 15 to 20 different control systems, and we just tried until we get one that people want to use. And the last point on this is that there's a tendency with computer-based things for an older generation of people that support plants to say, I'm fine. Give me the drawing. I got to print it out. I don't want to see that type of stuff. It's actually funny because when we put on some of this technology like VR and AR, for example, they can walk around it like they normally walk. Like we have a big enough VR room that, we get the question of, well, how do I move around? And we say, well, use your feet, just walk. So all of a sudden we have people that don't like to sit down with a mouse and technology aren't afraid of it because they walk up to that furnace and they can crouch down and look around, and they they get it right away. And then you can start to see what it means to them, right? So prototyping early, getting in front of the potential of it. It's not just a better way to look at 3D models. It is something that we just can't do. It's something new, but I think that's how you build that support.
A couple rapid fire questions. So how long does it take to build this software for a plant? And what would be the average cost to create a VR simulation?
It depends what you want to do, right? So if I look at, so what you saw in the demo for VR, we've been working on this for about 4 years. So we've taken training, video game training from Unity themselves to teach us how to do this. And we've been churning away with our models on a workflow. So for us, the demo that you saw took about 2 weeks to build, right? And it's just a dumb demo, right? With some colors and you can move around in a control scheme we built ourselves. We're just in the process of trying to figure out how we build our entire facility as a set. And our challenge is it's so graphically dense. One of the terms the industry has is polygon count. Our plant site's over 3.3 billion polygons. There's no technology that renders that. So as far as cost goes, I guess I'll answer it 2 ways. If you have the model now, like let's say you're a company that's got a Viva or Bentley or Hexagon Intergraph, you've got some models that you can start to build with to create your set, right? And it's actually, the cost is really the software, right? You know, Unity and Maya, for example, as something to fix your models with. And then it's really time, right? It's the cost of, I have a 3-person department that builds all these things from that point of view. And then the headsets are cheap, right? So Facebook's Oculus Quest 2 is, you know, $500. The room scale stuff is probably $1,200 for that type of technology. The HoloLens for holographic, it's about $3,000 to $5,000. That's a little bit more development cost from that point of view, but it's actually quite cheap to create a prototype, right? What you do with it, you know, is really where some of those types of costs go. If you don't have a model, then it's a lot more work because you need to manually create something that looks like your model that you're trying to model against. So it really depends on, but my advice is to try small and just try stuff, right?
Okay, so what was the name of the program mentioned earlier in your presentation? And do you know any other companies using this program / technology?
Unity, you mean? So Unity is our development tool. So there's 2 video game development tools in the industry. There's Unity and Unreal Engine. And a lot of mobile games are written with Unity and a lot of high-end console video games are built with Unreal Engine. We chose Unity because a lot of the VR, AR headsets are like mobile devices. They're limited, they got slower processors, and some of the software itself has things that help us support being able to develop in that. So that's what we use. We're a Hexagon Intergraph shop, so our source models are in that format. And then we bring them into Unity and we just follow a video game workflow. Unity uses a FBX format, which is a standard for how graphics are moved between any kind of development into a video game development software engine.
So that's the end of our questions. I just wanted to share a comment that Anastasia made. She basically said that the VR experience is an interesting concept in our new COVID reality, and that in-home services like plumbing or electrical issues can be completed by the homeowner, eliminating the risk of exposures with technicians entering the home. So if you wanted to comment on that and just we can just get it wrapped up.
Yeah, I think when you look at the example of the training with the HoloLens that we have with being able to put augmentation over reality, one of the things that Microsoft does have is the ability to do remote calls that way. And the HoloLens has a camera to see what you're doing and you can mark it up and overlay it. One of the things that we are experimenting with VR is having 2 people in the same virtual reality and you see somebody else as a floating head so that we can have those distance. I can sit in my office here and somebody else can sit in another remote location, but in VR, we're side by side. So that is where this technology is going. There's a lot of video game and proof of concepts of doing those types of technology. We're trying to take that multi-person in the same virtual world and apply that to the industrial view. So that question is bang on of where this is going.
Okay, I think that wraps things up. Thank you so much, Steve.
All right, have a great day, everybody. Thank you.